These are the actual questions interviewers are asking in JavaScript interviews, whether it is for a front-end interview or for a full-stack interview. I have been interviewing for the last 11 years, and these are the most common questions I've seen being asked in interviews. So if you're preparing for interviews, make sure you do each and every one of them. Hello everybody, my name is Shruti Kapoor, your favorite developer, entertainer, content creator. And in this video, I will bring you solutions to 6 of the most commonly asked interview questions. This is part of my 31-day JavaScript interview question series, which you can find right here. And hey, if you like this, give this a big thumbs up. If I get 100 likes on this, I will make part 2. So let's dive right in. Okay, now let's do LRU cache, least recently used cache. This is a common example of how cache works in browser. Let's take a look at how this works. Here's the properties of LRU cache. It stores a limited number of items, which is determined by the capacity. This is what gets passed to the constructor. When it reaches capacity and a new item is added, it evicts the least recently used item, hence the name least recently used cache. So for example, we can add items to the cache. Let's say we have a capacity of 2, we put 1, 1, we put 2, 2. It adds it to the cache. But if we put another item, it removes the key first, which would be the least recently used key, and then adds the new key by removing the previous key. So it can only have as many items as the capacity allows. Now, accessing an item makes it the most recently used. That makes it a least recently used cache because as you keep accessing items, they get added to the top of the queue as in they have been accessed. Now let's see how this will operate. So if we get an item, like we said, it goes to the top of the list. We have to remember that. Then if we get the second item, it goes to the top of the list again. And this way we keep moving items that are not used at the bottom of the cache. Now, if an item does not exist, it returns -1. Let's implement this. We're going to start in constructor, which accepts a capacity. And for the purpose of this, we're going to give it a capacity of 2. Now we need a capacity. This gets initialized to capacity. And then at this point, we're going to use a cache. Now we're going to initialize a data structure that is going to be our cache. Which data structure do you think makes sense here? There's a lot of different ways of thinking this, but a data structure that will make sure that we have a constant access time, constant insertion time, and constant delete time is going to be JavaScript map. And here's why JavaScript map is helpful. It has a constant read, write, delete, and it automatically keeps track of insertion order. So if you add an item, it automatically gets added to the top of the list. So that means first inserted will be the least recently used. So all we got to do is remove the first item of the map. Therefore, our cache is going to be a new map object. And this is all we got to do to construct this. Now, putting it is an interesting operation. When we put, we need the key and the value. So how do we put an item in a map? We know that's easy. All we got to do is this dot cache dot set, right? Add the key, add the value. However, what if the cache already had that value? Remember in least recently used cache, if you get an item or if you touch an item, it becomes an actively accessed item and it moves it to the top of the list. So in order to make sure that an item gets to the top of the list, what we can do is remove it from its previous location. So what we're going to do is this.cache.has key. We just got to make sure that we delete the previous location because when we set it, it automatically adds it to the top. Nice. Okay, this is if we have capacity to set item. What if the cache is already at capacity? Remember we said that if it is at capacity and a new item is added, it evicts the least recently used item. How do we know which item is the least recently used item? We know that because first inserted is the least recently used item. So basically all we got to do is find the first item of that cache and remove that. And actually because we have a map, finding this is easy. So what we're going to do is check if this dot cache dot size is equal to this dot capacity. If we are at capacity, we're going to remove the first item. Evict the least recently used item, which is the first key. Now, how do we find the first key? let's say const first key equals, now because this is a map, we could do this dot cache dot values. Because this is a map, we could do this dot cache dot keys. This actually returns an iterable, and the next property of the iterable gives you the first property of the first value of the iterable. So let's understand this. Let's say this is my cache. When I do this dot cache dot keys, this gives me an iterable of 1 and 2. So when I call this dot cache dot keys on this cache, it's going to give me a value of 1, 2. And because it's an iterable, I could use the next property to find the first key, the second key. So now if I start with next, it gives me the first key, and then I just gotta get the value out of it. That is the value of the first key. And this dot cache dot keys dot next dot value will give me the value of the first key. Now once I have the key, all I gotta do is this dot cache dot delete that key. Delete the first key. All I gotta do is this dot cache dot delete that first key, and that evicts the first item. Now once we have evicted the first item, if we have key, we delete that, so we update the reference, and then we set it. That's how we put. Okay, what if we have to get? Get is actually simple. In get, if the value doesn't exist, so if this dot cache dot has key, if it doesn't exist, then we return -1. If it does exist, then we basically have to return the value at that property, right? This dot cache dot get key. Now, however, one thing that we're missing is if the item exists, move it to the top. That's what we have to do. So for that, what we can do, the same thing that we did here. Let value equals this dot cache dot get key. We just gotta set it to the top, which is this dot cache dot set. We just gotta move it to the top. So first we're gonna delete this item, this dot cache dot delete the key, and then we just gotta set it at the top. This dot cache dot set the key with this value, and then we're gonna return this value, and that's basically it. Now let's run this. So we have a new cache. We have a LRU cache here with capacity of 2. If we put the value 1, 1, we're going to have 1 and 1 in LRU cache. If we put 2, 2, now we are at capacity. Now if we get the first key, it returns 1, but also moves it to the top, which means 2 is going to be the least recently used at this point. Now if we get 2, it moves 2 to the top, which means 1 is going to be the least recently used. Now we're putting another item in the cache, which removes the least recently accessed key, which in our case is going to be key 1 because we just accessed 2. So then our item becomes 2, 2 and 3, 3. Now if we get 3, which makes it puts it on the top, it returns 3. Now if we try to get 1, it's going to return -1 because we evicted -1. So let's log this and see if it works. Okay, so we see 1, 2, 3, -1. Perfect. All right, let's implement a debounce function in JavaScript. Now, what does a debounce function do? To understand what a debounce function does, take a look at this example. Here we're logging console log, and we're going to log whatever value of I is passed in. So we have a function here that runs 1,000 times. Now check out what happens when I run this function. You get this function executed 1,000 times, which is what we expect. But notice what happens when I add debounce to this log. If I log this debounce log, notice what happens. I only get this function logged once, and that is at the last time. So what happens in debouncing? Let's take a look at this working example to see how debounce works. So we have this trigger area, and as long as I keep hovering on this trigger area, the debounce function won't run. But if I move my mouse away, the debounce function fires 1 time. Let's reset it and try again. So I'm going to keep hovering on this, and as long as I'm hovering, nothing's going to happen. But if I move it away, it'll be fired once. And if I come back and start hovering and move away, it'll be fired once. So this is what happens. It actually prevents the execution of the function for as long as I am on the trigger area. But if after a certain wait, nothing has happened, that's when the function gets executed. Same thing is here. As long as I'm hovering on the area, nothing will get executed. But once I stop hovering on the area, after a certain wait has passed, that's when the function gets executed. And that is the main difference between debounce and throttle. So let's take a look at how to implement this. So in summary, what happens is if you keep performing the same function over and over again, the function will not get executed if it's debounced. But if you stop performing that function, or if you stop calling that function and wait a little bit, which is the timeout that you would have given, that's when the function gets executed. So what does that mean for code? If function is being called when the timeout is running, do not do anything and reset the timer. Why? Because we do not want to call the function until that function has been stopped calling for the wait time. So again, if the function is being called when the timeout is running, do not do anything and reset the timer, because we do not want the function to be executed for as long as that function is being triggered. And then after the wait is over, that's when we want to call that function. So let's make this. So as you can see here, this function returns, when we call debounce, it actually returns a function which we can then call with the argument that's given, which means that we need to return a function that accepts arguments, which means we need to return a function which would have arguments passed into it. And this is an arguments array, so whatever gets passed in here, which is right here, that gets passed into this parameter called arguments. Now we want to have a timeout here, and in this timeout we're going to call our function. This is the function that is passed right here. But when this function is called, we want to make sure that we set it with the right this context. Why? Because after site timeout is executed, the context of this would have changed. So we want to make sure that we are taking care of this context as well. We're going to apply the arguments. We're going to apply this context and the arguments to this function. Now this is going to wait for this timer. And remember, if the function is being called when the timer is running, do not do anything and reset the timer. So let's reset that timer. Remember that set timeout actually returns a timeout. So if timeout is running, then clear timeout, which means it resets the timer. And now let's try running this. There we go. We only get this logged one time. And now let me show you how this actually works. So I have a wait of 500 milliseconds. And if I call this function within 500 milliseconds, nothing will get logged. It will only get logged after I stop typing and wait 500 milliseconds. So what we're going to do is actually execute that. I'm going to set a timeout here for log. And I'm going to log 1. I'm going to log hello. And then I'm going to pass it a timer, which is more than 600. So now let's try this. Once this function has logged, let's try logging another function called set debounce log, but I'm going to pass a 200 value here. And now I'm going to set the timer for 600. And then I'm going to pass in this function again. And I'm going to call this loop again with the timer of 500. So what do you expect to happen? Pause the video and tell me. Let's log this. Actually, to change what we may see, let's actually add 500. Okay, so now let's try this. I have one loop here that executes up to 1000 and then has a wait of 500. So let's run this. And now the debounce function only runs one time, and that is at the end of that execution of the loop. And if I have waited for 500 milliseconds, that's when that gets executed. To show you that actually runs only after 500 milliseconds have passed, we're going to do this as well. We're going to call this again, but with instead of going up to 1000, we're going to go up to 2000, and let's see what happens. So now if I run this, you see now I don't get this 1000. Why? Because right away after calling this, I'm also executing another loop where I'm calling the same function, but for 200 times. So now because of the debounce, this function wouldn't get executed as well. Because for debounce, we've got to stop calling the function and then wait that much time for the function to get executed, which is why my log is going to be 199. So I hope that makes sense. That is debouncing. Okay, so now that we've learned debounce, let's actually try to understand the difference between debounce and throttle, okay? So I have this function here where I'm debouncing and throttling the same function. So I've got console log debounce log and I've got console log throttle log. On one function, I'm going to pass a debounce, and on the other function, I'm going to pass a throttle. Let's see what the difference in output is. So I'm going to run this. And notice this. The throttle part runs first and then waits for the next function execution. Whereas the debounced part, the debounced function actually waits first for the user to stop doing something and then executes the function. This is a prime difference between throttling and debouncing. Now, the big difference between throttling and debouncing is that throttling ensures that the function runs at least once in 500 milliseconds, which is the wait time we've given. Whereas with debounce, the function will wait for 500 milliseconds before running again. So a prime example of where debouncing is used is in scroll events. So let's implement this. Okay, so we're going to return a function, and just like before, we're going to have a function and we're going to apply our this context and arguments. Now the prime difference here is that if we are already throttling, which is if we know that we've called this function before, if is throttling, then return, which means that we're already throttling and we got to wait for 500 milliseconds to pass or whatever the delay has been given. Let's also define this. Let is throttled equals false. All right, so if we're throttling, then return. Otherwise, apply the function that was given with the arguments that were given and set is throttle to true. Now, when the timer is over, we have to make sure that we are turning the throttle off. So at that point, we got to make sure that throttle is turned off. Is throttle is set to false at the end of the delay. Let's try this out. Okay, so it runs the first time, perfect. And that's how to do throttling. When I was preparing for interviews, there was one resource that was extremely helpful to me in helping me understand not only the questions that could be asked in JavaScript interviews, but also which questions could be asked for which company I was interviewing for. And I cannot tell you how many times I saw the same question being asked in an interview. That resource is greatfrontend.com. And I'm very excited to partner with them to bring this resource to you to help you go through your JavaScript interviews. This is how I prepared for my interview. I did all of these JavaScript interview questions. I also did the user interface questions, and then I made sure that I was following questions for each of these companies. And some of these companies, I'll take questions exactly from this question bank. So make sure you do questions from this list and increase your chances of passing that interview. The link is right here, or you can find it in the description. Good luck. I'm sure you're going to be successful in your interview. Let's get back into it. This interview question is actually one of my favorite interview questions to ask as an interviewer, because not only does it give me an idea of how well they know JavaScript fundamentals, it also helps me understand if the candidate understands object inheritance, the concept of this, and breaking down a complex task into digestible functions. So let's get into it. We're going to implement an event emitter class. Now what this function does is, this is similar to how you would have in Node.js or how you see in browser. So you can create a callback function. For example, here I have on scroll, on type. I can add an event such as scroll, and I can add callbacks to it. So I can register for an event scroll, and I can register a callback. I can also register for different type of events such as type, and then give it a different callback. Now once I emit that event, any callback that has registered for that event, such as scroll, should be executed. In this case, I only have one function so far, which is console log scrolling, so I get an output of scrolling. Next time, so if I turn off that callback, or rather deregister that callback, next time that event is fired, nothing happens because on scroll is turned off and we don't have any other callbacks. Now, if I emit a different event, such as type, that callback still executes because somebody is still listening to that callback. Let's log this. There you go. We get scrolling and typing, and we do not get anything for this emit because nothing was registered. So let's implement this. Okay, so we should have an emit emitter class similar to the one in Node.js. It should have an on, off, and emit method. When the event is emitted, any function that has subscribed to that event should fire. So let's go ahead. So first of all, we're going to need a constructor. We're going to need an on function. We're going to need an off function, and then we're going to need an emit function. And we're going to come and implement them in a second. Now let's look at how this is called. when event emitter class is called, we want to be able to store events, right? So what we're going to do is we're going to initialize this class with this.events, and we're going to initialize this with a blank events. Now, when we want to register an event, which is on an event, we want to know what event it is and what is the listener. In this case, what we want to do is we want to push this event in the events object. But hold on, what if the events object already has an event of this type, such as scroll? In that case, if this.events is not empty, then we simply want to push to this event a listener, which is if the event scroll is already registered, we want to push another callback to the same event. Else this.events event is a listener. Okay, what happens on off? At the time of off, we're going to be given an event and we're going to be given a listener. So when we turn it off, all we got to do is go through the listener, go through the events array, and remove the specific listener, right? So how can we do that? We're going to take out all of the events from this.events at event. So in the case of off, we're simply going to look at all of the listeners of that specific event, and we're going to filter out the event that we're going to filter out the listener that we want to remove and set it back to this.events. Now, what do we want to do for emit? Remember, in the case of emit, we actually have an event, and we could optionally have arguments as well. So in the case of emit, we just need to remember to call all the listeners of an event, and we're going to do if listeners, then we're going to call if listeners. We're going to go through each of this, and if listeners exist, we're going to go through each of this listener and just call the listener with the arguments that are passed, and that's it. And now if we run this, oh, hold on, what did I do? If this.events.event does not, if this.events.event exists, then push it. Otherwise, we want to put this into listener. How about that? There you go. Scrolling and typing. Perfect. That's how you emit an event. Now, in flattening an array, we have to implement a function which recursively flattens an array into a single level. Here are some examples. If it is a flat array, it should just return back that array. However, if it's a deeply nested array where each element is an array, it should return them back into one level. And it doesn't matter where this array is. If it is an array, it should return back as a flat array. So let's try this out. Now, what do we want to do here? We want to first check if the element is an array. If it is an array, flatten it, which is recursively call this function. If it's not an array, just return back that element. Then move on to the second element. If it is an array, which in this case it is an array, flatten this, which is call this function with this subarray, and then return the value given back from that function. So we're keeping track of the accumulated value so far, the flattened array so far, and we have to keep track of the next element. So this is where reduce will be super helpful. So we're going to use array.reduce the accumulator and the value, and first I'm going to give it a blank array, which is where my accumulator will add values to. Now, if value is an array, which means the first item is an array, we want to flatten this array and concatenate it back into accumulator. However, if the item is not an array, we want to simply return that value back and add it back to the accumulator. The advantage of having accumulator and reduce here is that it automatically pushes the flattened value back into the array. So you don't have to manually keep track of it. Now let's run this. So all of these arrays are flattened. And that's how you flatten an array. Another function that gets asked a lot and is an easy one to master is memoize. Let's take a look. Memoize is how you can cache the value of a function and store it so that if the inputs are the same on the next call, the function doesn't have to re-execute and it can return back the saved value. Let's take a look. So in this case, I have a function memoize add 1 and 2. First time it actually calculates the sum. So say it's calculating sum. And the next time this function is called, it actually returns back the sum instead of calculating it again. And the next time when the parameters are different, it actually then recalculates it. Now, if I was to run this function again, what do you think would happen? It returns cached 5. So let's see if it does. And there you go. So let's implement it. Okay, implementing this function is easy if you just remember to use the right data structure, which is map. You could also do this with plain JavaScript objects. Map just makes it easy. So here's what we're going to do. We initialize a new cache. We're going to return a function which could take some arguments. And now in order to put a value in the cache, we're going to create a key. So the key is just going to be the stringified version of the arguments. This keeps it easy. This makes it easy to understand when the arguments change, the key changes as well. So we're going to just stringify the arguments. And now in order to implement the memoize function, all we're going to do is just check if the cache has key, then return the value of that, then get that key and return it. But if it doesn't, we want to set that key in the map. So first, otherwise, we're going to get the result, which is actually calling the function with the arguments that were passed. And now we're going to put this result back in the cache. We're going to cache.set with the key. We're going to set the result. And then we just got to return the result back. Console.log memoize return. Let's add this memoize return. And then in this case, let's add. Okay, let's test it. There you go. The first time we call the function, it calculates it. The second time it returns the memoize value. Same when the parameters have changed, it calculates the sum and then returns the cached value. And that's how you memoize a function. If even one of these questions made sense to you, give it a big thumbs up. If you've seen any of these questions before, tell me in the comments which question you've seen before. And if you want part 2, hit that thumbs up and I'll make part 2. But don't stop here. This is part of the 31-day interview question series. Make sure you do every single question in this series. Find that playlist here.